Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7, part C, from the 0580 syllabus of the International GCSE IGCSE Cambridge, paper 4, variant 2 from February-March 2020. Parts A and B have been answered on separate videos because A and B are about different topics than this, so I want to save this according to topic as well as paper. So this is about sequences, number patterns and sequences. C part 1, here we have a series of numbers. We have to try to find the nth term of the sequence for each of these, 1 and 2. Now if you look at part 1, we have to try to determine what pattern there is that takes us from one number to the next, and then we can work out how to find the nth term. The nth term meaning a formula that will give you the entry for any term that you want to find. For example, if you want to find the fifth term, you just put n equals 5 into the nth term and it will give you -4 and so on. So what we have to first determine here is how the numbers are changing from one to the other. And if we see the difference between the terms, if I want to go from 4 to 2, I have to take away 2. So it's subtract 2. From 2 to 0, again, I have to subtract 2. From 0 to -2, I have to subtract 2. And from -2 to -4, I have to also subtract 2. So each time you have to subtract the same number. Okay. And so when you find that to get from one term to the next, you have to add or subtract the same number, then it's got something to do with that number's times table. Okay, so subtracting -2 each time means it's got some relationship to -2 times n. Okay, that's going to cause the sequence to go down by 2 each time, right? So like, for example, for n equals 1, I'm going to get -2. N equals 2, I'm going to get -4. N equals 3, I'm going to get -6. So it's going down by 2 each time. Okay, it's going down by this number each time. If I put 3n, that's going to cause something to go up by 3 each time. 3, 6, 9, and so on. All right, so because it's going down by 2 each time, it's got something to do with the -2 times table. So I'm going to write -2n. Now, that's not going to be our answer because we want the first term to be 4. We want it to start from 4 and then start going down by 2s. So if I think about the first term, if I left it like this, the first term would be -2. I want the first term to be 4. How do I go from -2 to 4? What do I have to do? Well, I have to add 6. If I add 6 to -2, I'm going to get 4. So I have to add 6 to this term that I have here, and that will make the sequence start at 4. Okay, and for example, if I put n equals 2, the second term, I'm going to have -2 times 2. So this is the first term, this is the second term, this is the third term, this is the fourth term, fifth term. If I put n equals 2, I have -4 plus 2, which is 2. N equals 3 minus 6 plus 6, which is 0. N equals 4 minus 8 plus 6, which is -2, and so on. So you can see it gives us our sequence. So this is our answer. We can write it like this, or we can write it like this, 6 minus 2n. Both of them are perfectly the same and perfectly fine. So that's how you deal with this type of sequence. This is called a linear sequence, where you have to multiply n by whatever number comes up when you are looking at the differences in this is called the first row of differences. All right, so if you have to add or subtract the same number each time to get from one term to the next, it's got something to do with that number times n. And then you have to adjust it by adding or subtracting something to make it start from the place you want it to start from. Okay, so that's part 1, 6 minus 2n. Okay, now part 2, if we start off in the same manner by trying to see how to get from one term to the other. See, from 1 to 7, I have to add 6. 1 plus 6 is 7. 7 plus something gives me 17. Well, that's plus 10, so it's not the same number now. 17 plus something gives me 31. Well, that's 14. 17 plus 14 gives me 31. And 31 plus something gives me 49. 49 minus 31 is 8 and 1, 18. So we can see we don't have a common number in the first row. We don't have to add or subtract the same number each time, but there's something else to it. So what we're going to do now is we're going to go to the second row, and I think you can spot very clearly that to get from one term to the next of the second row, you have to add a constant. 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 4 is 18. So every time the amount that you have to add to get to the next number is increasing by 4. Now, when you find that the second row gives you a constant like this, then it's got something to do with a quadratic sequence. It's got something to do with n squared. So when you find there's a constant in the second row, it's definitely got something to do with n squared. And furthermore from that, whatever number comes up in the second row, you take that number and you divide it by 2. Okay, so if that was a 2, it'd be 2 over 2, which would be n squared. If it was 3, it'd be 3 over 2, which is 1.5 n squared. This time it's 4 over 2, so it's going to be 2n squared. So I know it's got something to do with 2n squared. This sequence is related to 2 times n squared. So how do we now find the nth term? Now there are many ways of doing it. Okay, I prefer the way I'm going to show you. I might show you a separate way as well. I might show you a couple of ways of doing it. Let me just move this down here. Okay, so now let me show you a couple of ways of doing this. The first way I'll show you is the way that I like. So I'm going to take this 2n squared. So what I'm going to do, I'm going to write down n, then n squared, then 2n squared, and then I'm going to leave a gap, and then I'm going to write down my sequence. My sequence is 1, 7, 17, 31, and 49. So 1, 2, 3, 4, 5. That's n. That's the first, second, third, fourth, fifth term. That's the position of the term. Now I'm going to take n. I'm going to square it. That's going to give me 1. I'm going to take this n. I'm going to square it. It gives me 4. This n is 3. Squared is 9. This n is going to be n squared 16. And this is going to be 25. And then I'm going to write down what 2n squared is. So I'm going to take this n squared and double it. Plus 2, 8, 18, 32, and 50. So we can this is what it's got something to do with, our sequence has got something to do with these numbers here. It's related to these numbers here. So now we can see very clearly that there is a link. But how do I go from 2 to 1? Well, I have to subtract 1. From 8 to 7, I have to subtract 1. 18 to 17, subtract 1. 32 to 31, subtract 1. 50 to 49, subtract 1. So we can see that this line is all a constant of -1. So our sequence is going to be this. Our sequence here is 2n squared minus 1. That's what our sequence is. When n is 1, you have 2 times 1 minus 1, which is 1. When n is 2, you have 2 times 4, which is 8, minus 1, which is 7. When n is 3, 2 times 9 minus 1, that's 18 minus 1, which is 17. And so on. 4, that's going to be 16 times 2, which is 32. 32 minus 1 is 31, and so on. Okay, so you can see that this is the correct sequence, 2n squared minus 1. That's the way I prefer to do a question like this, but there are other ways. Okay, some people prefer to use another method. I'll make some space down here and show you the other method. Okay, so some people prefer to use that quadratic sequence is going to be in the form of an squared plus bn plus c. Okay, and for a we can use the same method, that it's going to be something to do with 2n squared. Okay, you can do that. And then you can choose, for example, when n equals 1. When n equals 1, the term ends up as being 1. Okay, as we know, the first sequence is 1. So the first term is 1. So when I put n equals 1, this whole thing is going to end up giving you 1. So 2n squared plus b times 1 plus c is equal to 1. Okay, and that way you end up with 2 plus b plus c equals 1. So we can say b plus c equals -1. All right, b plus c equals -1. Let's write that again. Okay, that's one equation. And you can say, for example, when n equals 2, you'll put 2 instead of n, so it'll be 2 times 2 squared plus b times 2 plus c is equal to, when n equals 2, the second term is 7. That's going to give you 7. So that's going to be 2 times 4, which is 8, plus 2b plus c equals 7. So we can say 2b plus c is equal to -1. So now we can find, we can solve these equations simultaneously. We have b plus c equals -1, and 2b plus c also equals -1. And we can, for example, use elimination. So we can subtract these two equations. I'll subtract this way. 2b minus b is going to give me 1b. C minus E is 0, minus 1 minus minus 1 is 0, so we know B is 0, and then we can find C. We can say B plus C equals -1, so 0 plus C equals -1, so C equals -1. So now we know what A is. As we mentioned, A is 2, okay, from the same reasoning that we found before. Okay, it's, you know, the second row, half of the second row, and we know B is 0, so we have A is 2, B is 0, and C is -1. So we can now write our sequence. That's going to be 2n squared plus 0n, plus 0n minus 1, plus 0n minus 1, which is 2n squared minus 1, which is exactly the same sequence that we got. Okay, this is using some algebraic kind of method, using simultaneous equations, and the method I used here is using some sort of understanding of the pattern. Once you realize it's 2n squared, how does that relate to this term here? You can just see how it relates. You have to subtract 1 each time, and you get your answer. Sometimes you end up with something here which is a sequence in itself. Like it might be like, you know, 1, 2, 3, 4, 5. Then you can say it's 2n squared plus n. All right, you have to just work out what the sequence is for that, and then add it to the 2n squared. All right, so that's how you find. And you'll see other examples of this in the playlist that you have that I've made for sequences. So that's how you find the nth term. Here we had a linear sequence, here we had a quadratic sequence, and I've showed you a couple of ways of dealing with that. I hope that was clear. Other questions from this paper, including 7 part A and B, will be found in the playlist, which will appear in this region here. You click on the link that shows here. The link that shows here will take you to other questions which are related to number patterns and sequences. And you can subscribe to my channel by clicking on this link here. Thank you for watching, and see you soon.